Okay, now let's look at the set of all triples x, y, z such that x equals y plus z. Okay, I'm going to claim that this is closed under addition. Okay, let's let x1, y1, z1 be one element of this space, one ordered triple, and x, y, z2 another ordered triple in this space, so that both x1, y1, and z1 and x2, y2, and z2 obey the condition that the x coordinate be the sum of the y and z coordinates. And that would mean, of course, that x1 would have to equal y1 plus z1, and x2 would have to equal y2 plus z2. Okay? So if these are in the space, the question then is there sum in the space? And the sum is clearly x1 plus x2, y1 plus y2, z1 plus z2. We just add the x coordinates, this is what we get. We add the y coordinates, this is what we get. We add the z coordinates, and this is what we get. Okay? Now, as I stated earlier, but I wanted to write it down here, x1 equals y1 plus z1 and x2 equals y2 plus z2, since both triples are in the space. What we need to conclude from this is that this thing is in the space. And it might seem kind of obvious, and it turns out that it is fairly obvious, but maybe not as obvious as you might think. I'm going to say that x1 plus x2, y1 plus y2, z1 plus z2, we want to say that this is in the space. If it is, then x1 plus x2 has to equal y1 plus z1 plus y2 plus z2. That this has to equal this plus this. And then, of course, these are still there. Okay? And I have so here. Yeah, it's okay. My grammar's going to work. Okay, I was a little worried there for a second, but it's been a few days since I did this, and I kind of lost track of what I was using the so for. We can't draw a conclusion, but we're going to draw a longer conclusion. Okay, well, that aside. Okay, again, x1 plus x2 would have to be y1 plus z1 plus y2 plus z2. And again, I don't like the word so there. I'll fix that in a minute. The question then is whether y1 plus y2 plus z1 plus z2 equals y1 plus z1 plus y2 plus z2. Well, you can expand this, and it's really kind of okay to do this, not as rigorous as it might be. You just remove the parentheses here and say that these match up term by term. You've got a y1 here, you've got a y1 here. y2 here, you got a y2 here. z1, yeah, you got a z1. z2, yeah, you got a z2. And that's all you've got over here. So these two have to be equal. Therefore, this is in the space. Now there's actually more to it than that. Formally, you would have to start rearranging things. Okay, you would want to maybe rearrange this side so it reads like this. And to do that, you would start by, it's hard to say this without writing, I don't want to write it. You can rearrange this by the associative law, and then you can reverse things and so forth. So you could maybe put the parentheses around y2 plus z1, and then reverse the y2 and the z1 by the commutative law, so the y1 and the z1 are next to each other, and the y2 and the z2 are next to each other. And then you want to reverse the y2 and the z2. No, you'd be okay. The y2 would be next to the z2. You'd rearrange the parentheses again, and you would have this. Okay, and easy to write out, but really kind of unnecessary at this point. Just by removing the parentheses, which you know to be a valid operation on real numbers, these all being real numbers. I guess that's implicit as well. You easily match up the terms on one side with those on the other. Don't like the word so, so I'm going to erase it. And then we just say thus x1 plus x2, y1 plus y2, z1 plus z2 is in the space. So the space is closed under addition. I'd be more specific, addition of ordered triples, but I don't have room. Okay, so that's what it takes.